Okay, hello guys, so welcome to my channel. Now in this video, we want to look at Riemann integrals, alright? So we'll be talking about a very important proposition from the Riemann integrals. Okay, now the theorem states that if we have, okay, let me just put it straight. Suppose that f is an integrable function on a closed interval a comma b, alright? And we have another function g such that g is an increasing function which is differentiable on that interval, closed interval ab, alright? So for f to be an integrable function, it means that f is continuous and it is bounded on that interval a comma b, and g here is an increasing function which is differentiable. That means that g is also continuous, alright? But it's differentiable, not integrable. So those two things are different. Now, g is an increasing function which is differentiable such that the derivative of that g, okay, is integrable on that interval. So g is differentiable and its derivative is integrable. Then it follows that if we have two such functions where the first one, f, is integrable on that interval, and the second one, which is differentiable, okay, that is g, the derivative of that differentiable function is integrable, then it follows that the the integral of f of x, okay, with respect to g of x. Now, this x is actually a point from that closed interval, alright? Okay, for all x throughout in the interval, so you pick any one, and it will work out like this. That if you take the integral of f of x with respect to the other differentiable function g of x running from a to b, alright, that it is the same thing as taking the integral of f of x times the derivative of the differentiable function, okay, and the derivative also integrable. So you multiply that and you integrate that over the x variable. We are saying that these two guys are the same. So go ahead and prove this, alright, for you guys to see. So let me just put down the proof. Well, we have a very important property, okay, one of the basic properties of Riemann integrable functions, that if we have two functions which are integrable, then their product is also integrable. So let me just put it down real quick. Suppose, right? Let me use P and Q are integrable. Now, whenever I say integrable, I'm talking about Riemann integral. Riemann integrable, right? Can put it down, R is integrable. So all this is just Riemann integrable functions. So suppose P and Q are integrable, which means that P and Q are both bounded and then continuous on this interval, alright? That is for the integrable, Riemann integrable functions. So suppose P and Q are integrable on that closed interval, okay, then the product P, right, and Q is also what? Integrable. That is also Riemann integrable. So that is the proposition we're going to start with, alright? And this right here is really going to help us a lot. Now look at this. We have f to be an integrable function, and down here we have the derivative of this, that is g prime, to also be an integrable function. That means that the product of the two, f and g prime, this is g, and g prime is also integrable, alright? From the proposition we have at the top. So it means that the product of these guys is also integrable. And let's just say we go ahead and put that down on a closed interval. Now, this is just a proof, alright? This is just a theorem. So this, I'm going to be making use of this. So the interval we are giving is from A to B. From A to B, like that. Okay, of this product, f times g prime, and then we are to integrate that over the x variable. Well, you know that f is a function of x and g is a function of x. In fact, let me just put it down. real quick. So we have f of x times g prime of x. Well, you know that from here, g prime of x can be rewritten as dg of x dx, alright? That is just the normal notation. In fact, so let me put this down as the integral from a to b of f of x times dg of x dx, and right here we just put down dx like that, alright? And what do you see? Well, we can see that this and this will just become 1, alright? You kind of cancel out. And here we see that the left hand side, which is the integral from a to b of the function, the product times g prime of x dx is going to be, well, since this and this are just gone, so we are just going to enter with the integral from a to b of f of x times dg of x. Alright? This is very nice because that is just what we have right here, and that is it. So we can just put down this box and shade it this way, and that is the proof. Okay. Anyway, that right there was for you, and thanks for watching. Please subscribe to this channel.